Dear learners, welcome back to Hybrid Electric Vehicle lesson series. Now we are moving into Unit 2, that is next module, Subsystems of Hybrid Vehicles. Once again, I am Dr. R. Venkatachalam, Professor, KSR College of Engineering. Let us move to the content of today's presentation. Power split devices, types of hybrid system operation, then hybrid vehicles operation modes, power split system for hybrid vehicles, control strategies for hybrid vehicles, economy of hybrid vehicles, then conclusion about the all content. Power split devices for hybrid vehicles is a combination of power which is derived from the IC engine as well as motor, electric motor, that should be properly combined whenever required or properly splitted and supplied to the wheel accordingly. So whenever a driver demands a power, he must be supplied with proper power in order to give good control over the vehicle and good propulsion of vehicle and good riding comfort of the vehicle, and in order to overcome the various hurdles and path managing of vehicles. So this is how power split devices for hybrid vehicle is more important. Now we will move to types of hybrid system operation. So micro hybrids, mild hybrids, fully hybrids, these are the three hybrid system operation. The micro hybrids is meant for start stop whenever the vehicle needs to be stopped immediately or stop the engine system, which is used to ideal start stop whenever a vehicle is moving in a traffic. It needs more stop start operations. So it requires frequent stop as well as immediate start whenever the driver needs to move. So this system will shut down the engine during idling and it will start whenever pedal is pressed by the driver. So this is how this hybrid is working. That's why it is called as micro hybrids. This will not power a vehicle in electric form. So next is mild hybrid. So mild hybrids which has motor and also it is limited power is there. It can assist the IC engine to propel the vehicle, or during the acceleration it can work along with the IC engine so that more power will be delivered. But even though it's a hybrid, it could not provide all electric propulsion. So this will also functions as regenerative braking. So it can regenerate the electricity and store power to the battery. So mild hybrids are low powered hybrids, we can say. Then full hybrid, or it can be sometimes called as strong hybrid, is a vehicle that is available in the market now. So worldwide it is available. India, it is significantly improved from year by year. So full hybrid also uses electricity by for driving the motor as well as IC engine in order to couple both the sources of energy in parallelly and seriously and combined manner. So three kinds of operation can be possible, and also it can assist regenerative braking system, so that can charge the battery with electricity produced while braking the vehicle. So Toyota Prius and Toyota Camry hybrid and Ford Escape and so many cars, they are operating with hybrid energy sources. So hybrid vehicles operation modes are classified into four types. First one is the A figure shows the electric only operation mode. So the battery supplies the power to the power electronics, and the power electronics supplies the required power to the motor. That motor will produce the mechanical rotation. That rotation is fed to the transmission box, so that will supply the power to the wheels. So only electric operation is possible. and hybrid with the electric assistance. Here the IC engine is there, it's yellow color, and it is coupled with motor through clutch. Here the battery is there, then power electronics is there that supplies the power to the motor, then it is to the transmission box and it supplies the power to the wheel. So it's a hybrid system. Then battery charging, the engine is running, motor is also running, that motor will act as a generator that will run that will charge the battery parallelly. The battery sources is that battery is powered by the excess energy from the IC engine. After driving the wheels, excess energy is converted into electrical energy that will be stored in the battery. The fourth condition, that is regenerative braking. Engine will not work, motor will act as a alternator or generator. So from the wheel through the transmission box, the motor will rotate, that electricity will be produced, that mechanical source will be produced as electricity that will be fed to the power electronics, and the energy received from the generator is stored to battery. This is how regenerative braking is working. So 4 modes of operation is possible. The power split system what we have discussed earlier is given in a detailed manner. Here the 2 motor generator is used here. One is small powered, which is coupled with IC engine. Then another one is a little bit high powered motor generator, that is MG2. So that is also used by the clutches. Here a power split devices, that is a planetary gearbox is here. So that will split the power according to the requirement from the final wheel, that is decided by the driver. Here the battery is there, inverter is there, then if battery supplies power to the inverter, that inverter has a electrical path that is fed to the motor generator 2. So that will directly drive the motor. It is a series or a small system. Then a engine is coupled through MG2, so both will work together, so it's a parallel system. If engine, then motor gear, that will be used to propel the vehicle, as well as excess energy will be stored to the battery. So it can pure electric motor also, it is possible through MG2. Then series connection engine MG1 is possible. The excess energy will be stored in the battery if excess is there, while regenerating from the wheel through this gear, then MG2 will produce the power and set to the battery. In the battery, the regenerative power is stored. Through MG1 also it is possible. So control strategy for hybrid vehicles. In order to control all the optimized operations, or in order to optimize the operation to achieve the maximum efficiency, so hybrid electric vehicle offers the control strategy that is classified into 2 types. One is optimization based, another one is rule based. In the rule based, there are major 2 classifications. One is fuzzy based, another one is deterministic based. In the fuzzy based, conventional fuzzy, adaptive fuzzy, then predictive fuzzy. In the name itself you can see that the fuzzy will work. Then deterministic based, the thermostat control, power follower, modified power follower, state machine. These are the deterministic based hybrid electric control strategies is used. In optimization based control strategy, so it has 2 major classification. One is global optimization, another one is real-time optimization. In the global optimization, linear programming, dynamic programming, then stochastic dynamic programming, game theory, genetic algorithm, then Poitrin's minimum principle PMP, then control theory. These are the global optimization control strategies. In the real-time optimization, economic fuel consumption minimization, that is EFC minimization, or effective fuel consumption minimization, So robust control, then model predictive control MPC, then decoupling control, then neural network, then particle swarm optimization PSO. These are the control strategies. Whenever the vehicle classification is required, it will be adopted suitably to control the all electronics related or control operations. So in order to maximize the efficiency of the vehicle. So whenever we prefer hybrid vehicles, the economy of the hybrid vehicles need to be studied and it should be adopted properly. So the main benefits of hybrid car is the greater fuel economy, with hybrids using up to 30% less fuel per kilometer than conventional fuel powered vehicles. That is, from 10% to 30% mileage will be improved when you use hybrid technology. By including an electric motor and regenerative braking, so hybrids offer greater fuel economy, so which is more efficient as well as economy when compared with CAF standards. Another advantage is hybrid electric motor include comparatively less gas usage. Since the efficiency is more, fuel usage is less, so vice versa, the CO2, carbon dioxide emission is less, so when compared to traditional gasoline or diesel engine. So most recent types of plug-in hybrid vehicles are emerging in automobile engineering. So the battery pack will be higher when compared to the full hybrid. So whenever the short commuting is there, you can operate the plug-in hybrid vehicle as electric vehicle for short distance. It can move up to 150 kilometers, 100 to 150 kilometers in electric mode. If you have charging facility at your home, you can charge and you can operate it. Whenever you prefer long trip, you can use IC engine also. So this hybrid will be more popular, but only thing, it has high buying rates because the electric battery package is higher. So in order to conclude this chapter, the power split devices, PSDs, are a key component to effective implementation of combined operation of IC engine as well as electric motor to maximize the efficiency of the vehicle. So using planetary gear set, the PSD continuously distributes engine power to the wheels whenever the electric generator gives or IC engine gives. So it has very conventional gear shifting by smooth operation. So it can give improved fuel efficiency and reduced emissions and enhanced driving performances. So PSD allows engines to operate its maximum or optimum efficiency, and also it supports regenerative braking and also flexible power management. It can give IC engine power or electric motor power whenever it is required. So the design and control strategies of this hybrid electric vehicle is little bit complex than the conventional vehicles. Though power split devices remain one of the most effective and widely adopted technologies in modern electric hybrid vehicles. So it is contributing significantly in energy efficiency, environmental sustainability, and overall vehicle performance. So with this, we conclude this chapter. Thank you all for your attention. Thank you.